So it is day 3 of FABTECH 2018. Big thing that I've been seeing that, I mean, it's unsurprising, but the fact that 3D printing is so freaking prominent everywhere. I mean, it was huge at IMTS, bigger than I've ever seen it, and even in this space, it's pretty big. TRUMPF, which is one of the big industries, or the big companies in this industry, they've got a 3D printer, direct metal laser sinterer. I got the chance to talk with Markforged again, a little bit more about what they're doing in that space.
My name is Alex Crease. I am a senior content engineer here at Markforged. Markforged specializes in high-strength 3D printing for manufacturing. And 3D printing in general, a lot of people think that it's going to eventually replace manufacturing as a whole, and what we really see in the industry is it's really 3D printing is a complement to existing manufacturing processes. And the biggest one is really tooling and fixturing. So this is a demo of a part from Centerline Engineered Solutions. They needed to manufacture in low volume a bunch of parts like this, and it was going to be too cost prohibitive to machine the tooling necessary to punch out these sheet metal parts. So actually we were able to 3D print them on our composites printer with continuous fiber reinforcement. There's all these different ways that manufacturing has evolved over the past couple years, and 3D printing is a big part of that. So if you need to machine a very complicated part that has has a lot of complex features that need to be machined, you can use a 3D printed fixture to hold that part in the vise during the machining process. What a lot of people know of as 3D printing is sort of these weaker plastics like ABS or PLA, where you're printing in one sort of basic plastic material that's laid out in sort of a matrix fashion. And what Markforged does that's really different and really unique is we inlay continuous strands of composite fibers into the 3D printed parts to really reinforce them and give them a backbone. This is an example of a more traditional plastic material. There's a lot of 3D printing materials right now that are chopped carbon fibers, where you have chopped fibers mixed in with a plastic like ABS, PLA, or nylon. And so this sort of represents those chopped fibers. And the interesting thing is that even with the chopped fibers, they boost the strength a little bit, but the overall strength of the part is dependent upon the adhesion between the different pieces of chopped fiber. So a part like this, if I apply any sort of weight to it, it's going to shatter. Now, if I take that same part and I apply these continuous panels to the top surfaces and the bottom surfaces of that part, now I'm basically connecting the critical loading surfaces. So I'm creating sort of a sandwich panel, sort of like an I-beam. And now, when I apply that same load, the part holds. And so that really shows you that continuous fibers in 3D printing are really a game changer, because you can apply those continuous reinforcement properties to the critical loading surfaces of your part to really bump up the strength, make them just about as strong as metal. So the continuous fibers really provide that strength and that reinforcement to make your parts strong enough for manufacturing applications.
And I know I mentioned before, but this place is huge. You can get lost multiple times.
Yeah.